So we've gone halfway down the path of turning this ball into its own self-contained object by using the actor class. Let's finish the process by creating a child of the actor class that fully encompasses this this ball object that we are going to want to put into our Peggle game. And so we're going to do that by creating a BallActor class, and it is going to extend the actor class. It's going to be a child of the actor class. Let's do that now. I'm going to create a new class called BallActor. And what this is going to do is it's basically going to take care of a lot of the ball construction that right now is sitting in my main Puggle file. That is, it's going to go through the trouble of creating the sprite for me and creating the physics body and setting up the body in the B2 world and all of that stuff. Later, it is also going to include some of the game logic, like detecting when it's fallen off screen. In fact, maybe we'll even show you that right now. But first things first, let's start creating our actor. So the first thing we want to do is make sure that our public class BallActor extends actor. And now we're going to want to create this. Most likely, if we think about our finished Peggle game, probably the two things we're going to want to specify when we create this BallActor are its initial location. We'll just call it location. And we'll make this a point. And our initial velocity, which, should I be consistent and make it a point? Yeah, I'm going to be consistent and make it a point, even though in a few moments we're going to be turning it into a B2 Vec2. And then there's one other thing that we're actually going to do, and I'm going to include this at the beginning of the parameter list because I actually find I need to do it for all of my actors, and that is to specify a parent. And it's going to be a display object container. Basically, because I'm going through the trouble of creating the costume within this BallActor, I need to know what parent to put it in, and I find passing the parent along is probably the best way to do it. So I think we're ready to start. There's one other constant that I'm going to add. We'll make it a private. And that's going to be the ball diameter, which we'll make 12 because I'm pretty sure that's the diameter of the ball in the Peggle game. I'm doing this here just because it seemed like the most logical place for it. All right, so first thing we need to do, and this is going to be fairly similar to what we did in Puggle. I could probably cut and paste the code if I wanted, but the first thing we're going to do is first create the costume, and then we're going to create the shape, definition, the body definition, create the body, create the shape, all the fun physicsy stuff we do when creating a body in B2 world. And the one other thing we probably want to do is set the velocity to match our parameter. We're going to be specifying the location here in the body definition. But we're getting ahead of ourselves. Let's create the costume first. So I'm going to call this the ball sprite. And this is a new ball. And again, if we look at the library and our Flash file, whoops, I guess I called it ball sprite. So I'll make sure I do that. And I'm going to scale this, to match that of my ball diameter. Do the same thing for the Y value. And then we're going to add the child to the parent. All right, simple enough. Now most of this should look pretty familiar to you. So we'll breeze through this pretty quickly. We want to specify the radius. By the way, one clever thing I saw today was rather than multiplying by ratio and dividing by ratio, somebody had created just a static function that was part of a class that was basically converting pixels to meters and converting meters to pixels. You might want to do that as well if you get tired of manually multiplying and dividing things. Anyway, now through some tweaking, I actually found that this ball behaved most like the one in Peggle if you set its density to something like 1.5, and you actually set its friction to be 0. And then its restitution, its bounciness will be like, I don't know, something like that. That seemed to work out well for me after some fooling around with the values. Anyway, let's go to our body definition. And I'm actually going to set the position at this point to equal my location. Again, because location was specified in pixels, I need to convert that to meters. Now, there's one other thing I'm going to do here, but not now. I want to leave you in suspense. I want to leave you coming back for more. So I'm just going to mark a comment to myself that there's something I'm going to do here, but I'll talk about that a little bit later. For now, for the purposes of creating this BallActor, we don't have to do anything. I know, aren't you dying with anticipation? So anyway, create the B2 body, and we're going to do that by calling the world, and we're going to have it call the create body function, passing it the ball body definition. We'll have it create the shape from our ball shape def. Don't forget to call set mass from shapes so that our shape now has a mass and a center of gravity. And sorry, I guess I've gotten my comments a little mixed up. We've done that here. And so the last thing we want to do is set the velocity of our BallActor to match that of this initial velocity that we passed in as our parameter. And so I'm going to do that by I'm going to create a velocity vector, which is a v2 vec2. This will be a new v2 vec2. And we're going to do it by taking our initial velocity dot x, dividing by ratio, and our initial velocity dot y, and dividing by ratio. And then we simply call one function on our newly created ball body called set linear velocity. And this simply means set the velocity of our ball to travel in a particular x direction and y direction. It's called linear velocity because it affects the way our ball travels in the x and y direction. It doesn't affect the spin on the ball. That would be angular velocity, and we don't have any of that. Anyway, set linear velocity takes a v2 vec2 as the velocity of the center of the mass, and we've conveniently created one in the previous line, so I'm going to do that. And there's only one more thing we need to do, and that is call the super. And so now our body is going to be the ball body. And our costume is going to be this ball sprite that we've created. And I think that's all we got to do. All right, so now we're going to go back to our Puggle application, and we're going to change two things. First thing is I'm going to delete these member variables for ball sprite and ball body because we no longer need them. And this ball actor is no longer going to be just a plain old actor. I'm going to make it a ball actor. Now, if I go to my make ball function, I don't need any of this stuff. All I need to do is say BallActor equals new BallActor. Our parent will be the Puggle application, so I'll just say this. For our location, let's make a new point at 210. And for initial velocity, I don't know, let's 5 comma minus 1 times 3. I don't know. I don't know what this is going to look like. It's probably going to pop up very, very slightly. This is actually a fairly, in fact, let me make this a little bigger. It's actually a fairly small initial velocity because I am now defining it in pixels instead of in meters. I'm doing that just to keep all of the units consistent that I'm passing into this ball actor. And I can delete the rest of this stuff. As it so happens, this update now function being called works great because update now is part of the actor method and our ball actor inherits from actor. So I'm going to hit save and wonder just how many errors I'm going to run into when I hit F6 to run it. Huh. I guess it worked. Let's take another look at that, make sure it all worked. Seems to be going all right. That initial velocity seems awfully small. Let me make sure that's actually working here. All right, there we go. Now we got some horizontal velocity on that thing. Looks pretty good. Let's do one more thing as long as we're fooling around with this actor. You remember that child-specific updating function? Well, I'm going to override that here and just have it display a trace message when the ball has traveled off stage. So I can do that by saying override, and I believe the function is called child-specific updating. I think this is kind of neat. Flash fills in the rest for me. And let's just say if the costume's Y value is greater than the costume stage height. Pretty simple way of detecting if it's off stage. This is probably not what we want our function to do because I will be now displaying trace statements ad nauseum. But I think just as a way of showing that we now have some logic contained within that ball object, it's pretty neat. So there you go. Our ball actor is now its own self-contained object. It's got a sprite that it creates. It's got a V2 body that it creates. You know, sure, this whole kind of ball actor constructor is a bit of a mess. It's fairly complex. But the nice thing is now creating this, or creating several of these, is fairly easy and fairly straightforward in my main class. It keeps my main class pretty clean, which is good because I have seen some other Box2D applications where the main class ends up being sort of a giant mess. So if we're able to partition those giant messes off into other areas that we don't have to think about all the time, I think that'll make our lives easier. So this is pretty good. We've got a ball going. Let's create a few pegs so that we have something to bounce off of. We'll be doing that next.